Friends, Pushti sir again for the lecture 3 of the graphical explanation of loss in capacitor charging. In this lecture, I'm going to discuss the dielectric insertion. This is a very crucial topic which you have and a critical topic also which we face in the subtopic of the capacitor. So I'm going to discuss the energy loss in the process of insertion of dielectric in the capacitor gap while the capacitor remains connected to the battery, as you see here. We discuss in the graphical method. Dielectric is completely filling the gap. That you keep in mind. So this dielectric constant K is being introduced into the gap of the capacitor which is connected to a battery V0 whose potential difference is V0. Here I am taking potential difference EMF to be same. So I am drawing both the processes. One is extremely slow process. Slow means infinite slow I am taking. The other is fast process. Just see the graph in slow process. Initially the capacitor is charged to V0. After that dielectric be introduced. So as you introduce a dielectric slowly, very nanometer by nanometer. So since the dielectric get introduced to the gap, the capacitance has a tendency of rising. So the potential difference has a tendency of falling because if I don't change the charge, since the capacitor will be increasing, so the potential has tendency of falling, but battery has enough time to pump charge to arrest that falling process, means to bring it back to V0 without much falling. So for a slow process, the tendency of the capacitor is trying to the potential trying to fall, but battery is pushing the charge, so bring it back to V0. Again capacitor potential trying to fall, but battery pushing the charge. So like this, the small undulations in the charging graph appearing. So charging graph is undulating curve. That is this type of wavy type of graph. So the area bounded by the charging graph and the V0 line, that is a very small areas, they add up to the loss, as we have discussed in the previous lectures. So if I make the process infinitely slow, these wavy structures, these undulations, they become negligibly small. So loss becomes almost zero in a infinite slow process. That's what we have discussed earlier, and now also the same thing is true. Okay. So that's what I written. Battery has enough time to push up the charge to maintain the potential of V0. So the charging graph is an undulating line. The loss areas are the area bounded by the charging graph and V0 line. And those areas are very small areas. So that picture you have seen, when the process is infinitely slow, the undulations become negligibly small. So loss areas become almost zero. So U loss becomes zero. So this is the important point to note. Okay. So in an infinite slow process, loss is zero. Even if the charge is flowing within a very small kinetic energy, negligible kinetic energy, and loss is limited to kinetic energy only, beta. So loss will be almost negligibly small. We take it zero, right? Okay. So now you go to the battery work done. Extra charge which are pushed of the battery is final charge is how much? Initial is Q0, final charge is KQ0. So CV0 is the charge, C0, V0, Q0. So K times C0 into V0. So KQ0 is the final charge. So what is the extra charge pushed up by battery? This K minus 1 Q0 is the extra charge pushed up by battery. That is delta Q. So how much work battery will do? Its own potential into k minus 1 q naught. So that is nothing but, this is nothing but this rectangle area A, B, D, F. This k minus 1 q naught into V naught. Rectangular area is the battery work done. Initial energy, final energy. Initial energy is this energy. Just before dielectric introduced, it was already charged by the battery. So I already told you in the lecture 1, this is the area. OAB is the initial energy. Final energy is OFD area, half k q naught into V naught. So that is this triangle is the area is the UF, this is UI, and this rectangle is the battery work done. Loss is 0. So only one thing is remaining, WM, mechanical work done by the capacitor, because as dielectric introduced, the fringing field will try to pull it in. So it is doing some mechanical work. So we want to find that mechanical work by the capacitor. So now come back to this. So write the areas. Delta WB is ABDF rectangle, UN is OAB triangle, UF is OFD triangle. Values also I have written side by side. So applying the energy balance law, this is the most important law, which normally you don't see in the books. What is the most important? What is this? U initial plus delta Wm minus U loss minus delta, this is not delta M rate. This is what you should correctly. This is delta WB, initial energy plus energy supplied by battery minus loss minus mechanical work done by the capacitor is the final energy left with the capacitor. This is the very, very important expression. Okay, fine. So you use this. This triangle is OAB, UF is OFD, as you know. This delta WB is the rectangle ABDF. U loss is 0. So delta M, you can just add those triangles, add those triangle in OAB triangle, ABDF rectangle, minus karo OFD triangle. So you get ODB triangle. So I am showing you the diagram. This triangle plus the rectangle that makes up the whole thing, makes a trapezium minus this final energy. So that left with this triangle only, ODB triangle. ODB triangle is your what? Delta WM. That ODB triangle is delta WM. Okay. This ODB triangle is the delta WM. So half dB into BA, you can just check that. That ODB triangle, what is the area? A base is dB, half dB into height is BA. So dB is k minus 1 q naught into V naught. That's it, over. So half k minus 1 q naught V naught is k minus 1 into initial energy. This is the delta WM. Delta WS is delta W U loss is already 0. So it is both together, delta WM and delta WM plus delta W loss will be always U initial plus energy received from the battery or work done by battery minus U final. That's it. Now come to the first process. In the first process, you suddenly inserting the dielectric. So the capacitance potential, which was V naught earlier, suddenly falls to V naught by K, and the capacitance increases to Kc naught. That's what I wrote. So capacitance value jumps to Kc naught, V cap falls suddenly to V naught by K, as the battery cannot supply charge instantaneously. So the potential falls directly, suddenly from V to E. So that is V to V naught by K. So the drop of V naught into 1 minus 1 by K, this V line, it will, after that the battery battery knows that the potential has become, there is a potential difference between the capacitor plate and the battery end. So it will send charge, and that charging line will be a straight line because that is 1 by k. C naught should be its slope, and that will pass through the O, and this is the new slope. Okay, I have written a wrong spelling for slope. Okay, so the slope is 1 by k C naught. This perpendicular, this is an F. Okay, so now the area between the charging graph, which is the E line, and the V naught line, and Q is equal to Q naught to Q k C naught. This triangle area is the loss, that is the maximum loss, and that is the loss in the fastest, quickest process. So that's what we saw here. The loss को मैं दिखा देता हूँ. Loss will be that BED triangle. Obviously BED triangle. So that is half BD into DE. What is BD? K minus 1 Q naught. What is BE? V naught minus V naught by K. So half into product of this base and height will give you the loss. Exactly half K minus 1 Q naught into V naught 1 minus 1 by K. That gives you K minus 1 whole square by K, half V naught Q naught, or U initial K minus 1 whole square by K. That is U loss. But for the battery work done, same thing. See, it's sending the same, just like previous situation. It is sending the same charge, extra charge K minus 1 Q naught across its constant and potential difference V naught. So the work done will be this rectangle area K minus 1 Q naught into V naught. This rectangle area, that is ABDF area, just like the slow process. So battery work done K minus 1 Q naught into V naught, that is ABDF rectangle area. That's it. Because battery extra charge is K minus 1 Q naught, that is the horizontal line. That is the extra charge is this line, A to F, same as B to D, and the potential difference, constant potential difference during the charge transfer by battery is V naught. So battery work done is this ABDF. So loss in the area bounded by the charging line is ED, that I calculated already. U in K minus 1 whole square by K, right? U initial is OAB, U final is OFD. That looks like the previous situation. OAB area is the initial energy, half Q naught V naught, and final is the half K Q naught V naught. That is AFD triangle. Was very good. So now apply the energy balance law. U initial plus delta W battery minus U loss minus U loss माइनस साइन and थोड़ा ठीक से लिखता, अरे बार बार ये U loss minus U loss. Okay, U initial plus the work done by battery minus U loss minus work done by the capacitor, mechanical work done. Remaining part will be stored as the final potential energy of the capacitor. So already this I know, this OAB area, this I know is a rectangular ABDF, this I know UF is equal to ABDF, this is BD. Okay, let's just see. OAB area initial, rectangular area ABDF is delta W battery, minus U loss is BED, the triangle BED is U loss, this triangle is BED, and the ABDF is the rectangle work done by the battery, and final energy OFD triangle, final energy. Just see this. So final energy OFD, delta Wm I have to calculate, BED is the loss. So delta Wm will be just add these two, this triangle, this rectangle, and subtract these two triangles. That is delta Wm. I am going to the graph directly. Add this initial energy plus work done by the battery, this rectangle. So that makes this big trapezium. Then subtract from it the loss, this triangle, and subtract also this final energy. So that will get the delta Wm is nothing but this OBE area. Sorry, OBE area, this OBE triangle area. Let me see, have I written that? Yes, delta Wm is after adding OAB plus ABDF rectangle, subtracting BED triangle, and subtracting OFD triangle, I get delta Wm as OBE area. That OBE area is, let us see the OBE area. OBE area, this triangle, this base is V0 into 1 minus 1 by K, this line, and in the height is Q0. So half V0 1 minus 1 by K into Q0. So that is U initial 1 minus 1 by K. So U loss, and if I add this U loss and this delta Wm, you will get this term here plus this term here. I am adding U in, I take common. This addition will be simply K minus 1. Just check that. Okay. It will be simply K minus 1. K minus 1 take common 1 by K. It is 1 minus 1 by K. 1 by K cancel, 1 remains. So K minus 1 into U in. Here also U loss delta Wm summation is K minus 1 U in. Here also the same thing. So this one I wrote all this. The loss is maximum. The real processes are close to slow process only. That's why if nothing is mentioned, you take default process as slow process, no loss. So but if we mention that the first process, then you have to work like this. Actual real process losses and mechanical work done, the summation I know is K minus 1 into U initial, but each is how much? Not very easy to find in actual processes, which is neither very slow nor very fast. The loss is maximum in the infinite fast process. This is the maximum loss possible, as you can see in this graph. This maximum loss possible because the process is like this, they will come and like this. The areas, loss areas will be less than this maximum loss area in the real other processes, which are neither very slow nor very fast. So this is the maximum loss. In the graphical process, loss is directly calculated because from this triangle itself we are calculating loss. For analytically, I have to first calculate the work done because I'll approximate it to a isolated capacitor because battery has no role to play immediately in that instantaneous duration where the dielectric inserted, the battery is almost as good as not connected. So that will act like a disconnected from battery case. So that the loss is, that the work done is U0 1 minus 1 by K. Here also just you see you have done work done U0 into 1 minus 1 by K. Yes, U in 1 minus 1 by K, right? So but here the loss I am calculating in graphical process directly in the first directly loss. So from total K minus 1 in, if I subtract the loss, I'll get the delta Wm also. Sorry, delta M also I just calculated from the graph itself. So this is what I wrote. Okay. So I think you are now much stronger in appreciating why the loss takes place, how to calculate it. I think nobody can like you now. You can handle all questions regarding the losses in the dielectric insertion process. You won't face difficulties. So you go through my all the 3 lectures, and previously also when I discussed the capacitance and dielectrics, go through. I am sure there won't be a single question which you cannot answer. Okay, all the best and happy new year to all of you for a very successful year for you. Okay, we'll meet again with some other topic also. I'll revert back to electrostatics, but I'll take some other topic so that you feel comfortable in various physics topics. Okay, so regularly visit my channel, see and subscribe so that you get updates whenever I update anything, because every lecture which I give, something new is there which you may not find in books or materials. Understood this? But this will definitely make your life easier. Thank you all. We'll meet again.